What's the difference in a cotton picker and a cotton stripper? They are vastly different machines that accomplish the same goal of getting the crop out of the field, but the way they go about it is different. A cotton stripper, as the name implies, strips everything off the plant, leaves, burrs, lint, everything, and blows it into a basket. The cotton picker, every row unit, has hundreds of metal barbed fingers that rotate and they're on a track and they follow the plants along inside the row unit. The barbs, the spindles, are moistened by the machine so they can easier pick up the lint while they're twisting. And then once it picks the lint, it travels into the machine. The lint is doffed off of the spindle. It goes into an airstream and is blown into the basket. It's a lot more complex process with a cotton picker. You usually get a little bit higher quality turnout. Your lint is usually a little bit cleaner, but there's a significant increase in the amount of parts and the expenses and products that you have to have on a cotton picker to get that same product. They work better in really high yielding areas, usually over 2 bales an acre or 1,000 pounds an acre. In low yielding environments, like Oklahoma and West Texas, they don't work very well. And workers in this part of the country were apt to buy a cotton picker for that reason, plus the extra expense and the costs didn't pan out very well for low yield areas. So cotton strippers were developed as an economical, low cost way for people to mechanically harvest their cotton. And this is one of the earlier tractor mounted strippers sold by Allis. They were not made by Allis, they were made by the Central Texas Iron Works Company in Waco, Texas. They started in 1959 marketing these strippers through Allis-Chalmers. They ceased production in about 1962. One thing that I've heard a lot of people say that they liked about these Allis branded strippers in particular was just the ease of attaching and detaching them from the tractor, whereas competitive brands like International, John Deere, if you ever look at one, they're a much more elaborate machine. It takes a lot longer to mount and dismount one, whereas this one here, you simply back over it, hook up your lift arms and your PTO shaft. There's a couple brackets that would mount on the side of the engine frame rails for some hand levers that would control the height of the front of your row units, and then that was it. So if you only had one tractor and you needed to switch out for different jobs, it was a lot easier to do it with an Allis machine than it was any other. A lot of other manufacturers, people that had those, they would have a dedicated stripper tractor and just throw that on there because of the hassle of installing it. This stripper here is about a 1961 model. It's a Model 2S, and they were designed to fit the Allis WD, WD-45, D17, and D19 tractors. And it's just a simple machine. All it is there are 2 rollers inside each row unit, and they're smooth steel. And the plant goes in between the rollers. The rollers turn opposite directions, and as the plant is traveling through, those rollers turn and knock everything off the plant into an auger that's on each side. That auger carries the product back, or it is sucked up through 2 fans on the back of the machine, and then it blows it into your trailer behind you. Now on this model, the cotton gets sucked through the fans, so the impellers actually strike the cotton. And the one advantage to that is they have a lot more air power than competitive brands, so they could blow the cotton all the way to the back of the trailer very easily without having to have someone in the trailer to pitch it all the way back. The downside to that was, since the cotton was actually striking the fans, it led to a lot of seed crackage. The lint could be stained from oils in the seed. The quality went down. So that was one of the cons of this design, and probably a lot of the reason they didn't produce it for very long. After this stripper ceased production, Allis was out of the cotton stripper market for a few years. They decided to go again with an in-house design. They built their own stripper, and what we have next is their entry into the self-propelled market. In 1966, they unveiled 2 models, a 707 and a 707 XTB. They're essentially the same machine. This here is a 707. They were only produced for about 1 year. The 707 XTB was so well received that it continued on for a couple more years. The only difference in a 707 and a 707 XTB is that the XTB model has what's called a burr extractor. This was the first commercially available cotton stripper with a sawtooth type burr extractor on the market in 1966. It was a very revolutionary invention, and it drastically changed the way cotton was harvested because the burr extractor will remove up to 2/3 of lint and trash that's in the cotton that would ordinarily be left in the cotton by a machine like this without a burr extractor. They weren't too sure how the new burr extractor model would go over. It was heavier, it cost more, but it was very well received by all the customers, and they dropped production of the regular 707 after about the first year just because sales were so low. This machine here is the only actual 707 that I've ever seen, so we're going to strip with it a little bit today and see how it works and maybe compare the turnout of it compared to a XTB model. These strippers came new with a 2-row brush header like this. It's the same principle used in the older tractor mounted strippers. However, instead of steel rollers used to remove the lint from the stalks, the rollers now have a combination of nylon bristles and rubber flaps that are a little more aggressive, and they don't root the stalks out of the ground as badly, so they're a little more efficient at removing lint from the plant. There's still augers on each side of the brushes underneath, and they are slotted to help remove some of the trash that is in the cotton. And then from there, it's just blown up into the basket. It's a very simple design. There's not a whole lot to it. Power was provided by a 226 cubic inch gasoline engine. It's the same engine and skid that's used in a Cleaner E combine. It's about 60 horsepower. They were just trying to reuse as many parts as they could from machines that they were already building. The basket holds about 320 cubic feet, which is not quite a bale of cotton after it's ginned. And production numbers of these are unknown. I haven't seen very many of them. With the 707 and the 707 XTBs I've only seen about 3. So I don't know how many they actually built. This one is serial number 54. It's the lowest production one that I've seen, but they are around. They're just hard to find. The operator's platform is similar to a Cleaner E combine. The steering is a little different, but the transmission, the gauges, the hand controls are all quite similar. And let's see, that's about all there is on the 707. We don't have a 707 XTB here, but we have a 760 XTB here, which we'll talk about next. And a 760 and a 707 are pretty much the same machine. The only difference really is the engine. By 1969, Allis-Chalmers had quit building their own gasoline engines, so they went to GM for gasoline engines, and this has a GM 250 inline 6 gasoline engine that produces about 78 horsepower, so it is an 18 horsepower improvement over the 707. And we'll talk about the 760. They were also introduced as 2-row machines, originally with a brush head, and every 2-row machine would have originally had these fender skirts on each side of the wheel. I didn't have a set to put on this 707, but in low-yielding cotton areas, it's usually not too big of an issue. They just help keep you from knocking cotton off plants in the adjacent rows. In 1969, when the 760s were introduced, they came with the same 2-row brush head as used on the 707s. They also that year introduced broadcast headers. This is a 76-inch or a 2-row broadcast header. They also came out with a 4-row broadcast header that year. Allis-Chalmers was the first company to introduce a cotton stripper with a 4-row header, and that was in 1969. So that was another one of their innovations along with the burr extractor. The idea with the broadcast header is you have a header that's just as efficient as a brush header, but you have a lot less moving parts. There's about 11 bearings on a broadcast header versus about 8 bearings per row on a brush head. So you have a lot less maintenance, a lot less, virtually no wear, and you can harvest any row spacing, any angle you want. You don't have to follow the rows with a 4-row header. So that was something new that they pushed with the 760. Later on in the early mid-70s, Allis worked with the University of Tennessee on researching new ways of growing cotton on ultra-narrow rows. They were promoting people to plant it with a grain drill on 7.5, 10-inch, 15-inch, 20-inch rows, whatever the farmer wanted to try. And the idea with that was have a higher plant population. You'd shade out the weeds quicker because you don't have 30 or 40-inch rows, and then you wouldn't have to cultivate because they didn't have herbicides available for weed control post-emergence in those days. So that was what they were trying, and it was showing really favorable results. And then from what I've been told from a couple dealers that were close with the University of Tennessee, in the late 70s, they got a mysteriously large grant from a competing farm equipment manufacturer to drop the program and only focus on cotton pickers and cotton picker varieties of cotton. So I'll let you guess who that manufacturer was, but it might have been green. Anyway, so the broadcast system eventually fell out of favor, but Allis never stopped promoting the header. They knew what they had, and as you'll see out here, they still do a really good job today. We have on this trailer here a example of a burr extractor, and it's a fairly simple machine, and the overall design is still used today on new cotton strippers. And the way it works is cotton is blown in through the top through what's called a quad breaker. And it's just a shaft with a series of arms welded to it. And its job is to break up wads that may be blown in, help smooth and even the flow out, and break up cotton and help loosen it from the burrs. From there, it falls down onto the top saw drum. And this is just a cylinder covered in sharp saw teeth. And what happens is the teeth will grab the length and it'll pull it behind these sets of bars. And these bars help knock off burrs and leaves, and some of the cotton falls out of the top cylinder and onto the bottom cylinder, which is called the reclaiming cylinder. This is just a second step of cleaning to further improve the product. And it works the same way. It grabs the cotton and pulls it through these bars and helps remove more of the trash that would be in your cotton to get a cleaner product. Once the cotton is drugged behind these bars, it comes to the back side, which there's another cylinder that turns the opposite direction. It's called a doffing cylinder, and it turns faster than the saw cylinders do, so it sweeps the cotton off the teeth. Once it does that, the cotton is returned to the airstream and it's then blown into the basket. So it's an interesting design. It's a very simple machine. There's not a whole lot to it, and it does an excellent job improving the cleanliness of the cotton. The main reason for developing this was hauling cotton to the gin. You know, you may not live very close to it. It may be miles away. So if you have more trash in your cotton, you're taking more cotton to the gin, more trips, wasting more time, but you're not getting paid anymore because there's more trash in it. Well, by removing up to 66% of that with a burr extractor, you not only save time, but it reduces your ginning costs. And like I say, you save time because you make fewer trips to the gin with your trailers, because you only have so many trailers to use, and if they're all full waiting to be ginned, well, then that's just lost production time. So it was really important for farmers that they get cotton as clean as they could so they can make the most of their time. Talk about some of the competitors. To my knowledge, International Harvester never used a burr extractor of any kind on their machines. John Deere eventually caught up with the pace, but it was about 1984 before they made a burr extractor optional equipment on their machines. John Deere today is the only manufacturer of cotton strippers in America, so if you want one, that's your only bet. But we'll look at the 860 here next. The 860 is an improvement over the 760. The first thing that you might notice is the cab. The cabs for the 707s and the 760s were built by Ansell in Kansas, and they were probably pretty nice if you were stripping in December or January and it was real cold and it was blowing, but other than that, they're far less than ideal. They are cramped, they are noisy. So when the 860 came out in 1973, they now have the same cab that the Gleaner L and M combines do, which was a great improvement. They are much larger, much roomier inside, quieter. It's more of an integrated part of the machine versus just an optional accessory that you bolt on. The next thing that you might notice is the fans are different. On the 707 and the 760, they're mounted 90 degrees away from how these are. They're driven by a belt that has to make a curve, or it's like an L-shaped curve, and it's not a very efficient drive system. It's hard to get the belt tight enough where it doesn't slip. So on the 860, they located the fans, had a much better drive system for it. However, if you notice on the screen, it's got a bearing mounted in the screen. On the older models, there was one big bearing back of the fan and a smaller bearing just on the other side of that mounting plate that the first bearing is on. And having both bearings there and then your impeller out here, it wasn't very stable. It led to a lot of vibration and fan problems, so they went the opposite extreme. They put the bearing as far out as possible. They mounted it in the screen, which the screens are not very rigid. They're structural pieces. And so the problem that they had this first year was the screens would come apart just from the vibration of the fans. It wasn't a solid system. This was only produced this way for 1 year, and this is the only first year production 860 I've ever seen that didn't have cracked screens or blown up fans. So it's kind of interesting to see it here all in one piece as an example of what they should do. The catwalks on both sides of the burr extractor are made brighter. It's a lot easier to work on this machine from here than it is on the 760 and the 707 XTB. They start out wide in the front on a 760 and they narrow down quite a bit by the time you get to the back, and it's, again, they improved a lot with this. They made the right now 200 more cubic feet. It's up to 520 cubic feet. Power in 1973 and 74 is still provided by the same GM 250 gas engine. This one does run on gasoline. A lot of them were converted to propane. That was very popular in this area. Nearly every one of them was sold with a broadcast header. These were continuing to grow in popularity. On the 860, you could get your choice of either 716 steering tires or 1116s. This one has the 1100s on it. And an interesting thing about the 860s is, with the exception of 1975 and 76, they made enough changes to them every year that you can tell what year model it is just by looking at it. So 1973 had the fan bearings mounted in the screen. 1974, they took that away, as we'll see on the next machine. They put the bearing further in and relocated it in a more secure spot. In 1973 and 4, this handrail wraps around the side of the cab, kind of like a Gleaner E, or I mean a K or an F, and it goes through this mounting hole in the front. In 1975, they did away with that. It just comes straight, mounts to the cab, as we'll see on this next machine. 1975 and 6 were pretty similar, and then we'll talk about 1977 and 78 after that. Here we have 1975 860, and as I said, you can see the handrail doesn't wrap around the side of the cab anymore. It's just bolted right here. I'm sure the only purpose of that was cost savings and less materials used. In 1975, we also have the option to choose between the standard GM 250 gas engine or the new Allis 2800, the model 2800, 301 cubic inch naturally aspirated diesel engine. This engine produces about 85 horsepower, so it's an improvement over the 78 horsepower found in the gas 860s, plus everybody loves the diesel so much better. Fortunately, this one is a diesel, and I was very fortunate to come across this machine. It's a very low hour machine. It still has all the original saw blades in the burr extractor. The grid bars have never been moved or the paint cracked off the bolts. In 1975, they changed the design of the basket slightly. On the older models, the bottom and left sides of the basket were slotted with little stamped angle iron pieces. In 1975, they went to a solid sheet design on the left side and across the bottom. The idea with it on the older machines was dirt and trash would help fall out of the basket, but then they realized that all that piling up on top of the engine wasn't a good thing. So they changed it to a flat bottom design. The only thing I don't like about this design is it holds water. Again, we have the broadcast header. During this time period, you could still get the 76-inch broadcast head if you so desired, but those are increasingly rare. On the 860, as I said earlier, we have the Gleaner LM cab, but we have the operator's station of a Gleaner K or an F or a G. And why they made it that combine control system with this style cab kind of confuses me today. I don't know why they didn't just pick one and stick with it, but so it is a little bit different operating controls than what the L&M combines have. But aside from that, it's pretty much the same machine as we've previously talked about. So, as we can see, the fan bearings, they are now relocated behind the screen. They have 3 little support arms that attach to the fan housing itself. It's a much more secure system. They didn't give nearly as many problems that way. We don't have a 1977 or 78 model stripper here, but in 1977, they changed the design of the basket. We'll look at this one here. This basket design was used on the early 860 and back. So all the older ones use this design. And keep in mind, it was originally designed as a 2-row machine. So when your header stops at your drive wheels, your basket sticks out enough that you can pull up beside a trailer to dump. However, now that the 4-row header has pretty much become standard equipment, we have a problem. The basket does not stick out as far as the edge of the header does. So for those of you unfamiliar with cotton, but maybe you're familiar with combines, imagine a combine with an unloading auger that's about 3 feet shorter than the end of your header. Now, how do you go about unloading into the truck? The only way to do it is to back up to it. You would position your trailer here, you'd go past the trailer, swing around, and back up to it and dump. Now the problem with that, aside from being inconvenient, is you can only dump in one spot. So that presented a problem, and in 1977, Allis fixed that. They came out with a new basket design, which is the same design that's used on the 880. At first glance, it may not look like much, but when you go to comparing them, the frame and the pivot point are moved further out to the left, and it is now flush with the edge of the header, so you can again pull directly up to your trailer or your module builder and dump anywhere you want. So that was a really big improvement on the late model 860s. They also went to 2-way hydraulic cylinders on the basket in 1977. All of the older models had single action cylinders, which on a calm day wasn't a problem, but if you accidentally dumped with the wind, you couldn't get your basket to come back down. So by changing it to the 2-way cylinders, that greatly improved when you went to go dump. You didn't have to pay as much attention to the wind. I've stripped with this 860 a lot, and there'll be days where I position my module builder where I need it, and the wind shifts midway through a module, and it becomes a big problem. But they did improve that in 1977. One other thing about these early machines and these broadcast headers, they had an automatic header height sensing control, and it uses shoes on the bottoms of the fronts of the header. You have your header control lever inside the cab, and to activate this, you push it down into a detent, and then these shoes will float across the ground. It has a cable that's hooked up to a control box in there, and as it senses the rises and dips in the ground, it will vary the height of your header off the ground about this high. The design was that so you could kind of follow the contour better and get all the low-hanging bowls. I don't use it very much, especially in this field because it's got a lot of rocks. It's a big problem if you ingest a rock with one of these. It plugs up the feeder house, and then you've got a pretty big chore trying to get the rock out because they usually jam in pretty tight. But the 880, when it came out, the overall design hasn't changed much. They updated a lot of things. The burr extractor is the same size, header, feeder house. However, they have now reintroduced a brush head. You can get a 4-row brush head like it's on that 880 over there. That brush head is significantly heavier than a broadcast header, so they knew that they needed to update the strength of their machine. The 860s are based on a Gleaner K chassis, and they use the K final drives and transmission and those kind of parts. They've increased the size of the frame on the 880. They now share components with the F2, including the engine. They have upgraded to an Allis 433i turbo diesel. It's a 4-cylinder that makes about 95 horsepower. The transmission and final drives are the same as the F2, giving them the extra strength they need to handle the heavier 4-row brush head. Headers are now quick attach. On all the previous models, the header was detachable from the feeder house, but it's a lot more of an integrated piece. It's a lot easier to remove the header and feeder house together. On the 880, they made a great improvement. You pull out 4 pins and unhook your drive chain, and your hydraulic hoses for your header leveling attachment, and then you just back away. It's a really good design on the 880. We now have hydrostatic drive as standard equipment. All the previous models were manual shift 3-speed with a variable speed in each gear. Let's see. The only real way that an 880 gets more capacity than an 860 is due to horsepower increase and fan speed increase. They did increase the speed of the fans on these a little bit. That was how an 880 was able to get by running faster and higher yielding cotton than an 860 was. Aside from that, it's much the same machine. Basket extensions were available on an 860 to increase the basket size 100 cubic feet and bring it up to about 620. The basket on these holds about the equivalent of one bale of unginned cotton. It's about 2,000 pounds. Usually once it gins out, it'll be about a bale. So, does anybody have any questions about anything we've talked about or things I didn't talk about?
I have a question.
Yes.
In the back of the basket,
Well, okay, he's talking about the 860 and the back of the basket. On the top, there's a set of steel fingers that hang down. That was an option on all of the Allis self-propelled cotton strippers, and the idea of those was just to slow down the cotton before it hit the back wall, because the fans blow so hard that when the basket's empty and it shoots that cotton back there, over time it starts to push through the holes. So that those rods hanging down are just to slow it down so it's not hitting the back so hard. And let's see. None of these, well, some of these 880s have air conditioning systems on them. You can see by the white condenser box on the back of the cab at the top. The air conditioning became optional equipment in 1977 on the late model 860s. These broadcast headers, talking about those some more, one of the nice things about them is that you can change the spacing of the fingers in them. In lower yielding dry land environments such as this, you usually could get by with a full rack of teeth, which was 86. However, in irrigated areas where they typically have a lot larger stalks, what would happen is the stalks will get jammed in between the fingers because they're so big, and they'll get rooted up out of the ground, and it plugs the header up very quick. So to remedy that, they made it where you can adjust this. Each of these fingers is bolted to a square tube that runs across the bottom of the header. Each finger is held on by 2 carriage bolts. You can remove these bolts, you can remove fingers and respace them to get whatever spacing you want. Most of these have 86 in them. The first 860 down there came from an irrigated area northeast of here. It only has 69 teeth in it. So they are adaptable to changing crop conditions. It's not a hard job, it's just a very, very slow job. So it's not something you want to do very often. But yeah, that's how you set up a broadcast header. Does anybody have any questions? Okay, you got one?
Did they go from gear drive to hydro drive?
Okay, he asked when they went from gear drive to hydrostatic drive, and that was in 1980 when the Model 880 came out. The 860s were all variable speed gear drive, the 880s were all hydrostatic. All right, well, if we don't have any other questions, I think that's it, and give us a few minutes to get coordinated, and we'll start stripping some cotton here in a little bit.